Good morning, viewers. This is Kasturi Day. Today, as I've discussed earlier, that I'll be discussing the screw gauge today. Okay, this is according to ICSE syllabus class 9. Okay, so for starting this, in the starting of the video, I'll request you to please go through the videos and the text videos also, as well as the question answer videos which I've uploaded and will be uploading. Okay. So that will help you to grasp the chapters more easily. Okay. And also press the like button. That can motivate me to produce good videos for you. Okay, that can help you in your studies. And also please as I've told you earlier, for your increasing your concentration, please do meditate before sitting to study. Okay, so I'm starting with the screw gauge now. So see, the screw gauge looks like this. The picture, you can see the picture. There is a stud. Okay, this is an attachment of the screw gauge. It has a U-type of frame. There's a spindle which has this one, the B part, which is a flat portion of the screw. Okay, and in this gap between the A and the B point, we keep the substance, or keep the material which we want to measure the length of. Okay, and then to this U-shaped frame, a main scale is attached, which has a baseline, and there are graduations on the main scale. Okay, and there is a circular scale. It is a cylindrical cylinder-like structure, which is attached to the main scale, and the circular scale, that is called the circular scale, which has graduations here and this end, and the other end has a ratchet. Okay, it is a screw type, a handle, which is allowed to turn it is if we turn that ratchet, it will turn the circular scale. Okay, and the divisions of the circular scale will give the circular reading, which will coincide with the main scale reading. Okay, so in this way the screw gauge works. Okay, now let me start with. First, we come to the measurement of the length using the screw gauge. First is that a screw gauge works on a principle of a screw. Okay, so a screw gauge always works on the principle of a screw. What is the principle of a screw? Principle of a screw works on the principle of movements. Okay, which states that when the screw is rotated, that is in a linear motion, there is a linear motion on the main scale. So principle of moments, which states that when the screw is rotated, then that is screw gauge, when we turn the ratchet, then there is a linear motion on the main scale of the screw gauge that is equal to the distance between the two consecutive threads in it. That is, if we come to the picture, see, there's a screw here. When we are moving the screw gauge, when we are moving the ratchet, then the screw moves, and the distance of two consecutive threads. Okay, the distance of the two consecutive threads will give you there's a linear motion of the main scale, and this is equal to how much the motion is there. That will be equal to the distance of the two consecutive threads in it. Threads means these two markings on the screw. What is the distance between when the screw was, when the screw had this position, when the screw was in this position, okay, what was the main scale reading? And the second, when the screw was in this, after turning the ratchet, when the main scale, when the screw came to this position, what is the main scale reading? That will give the difference between them will be the principle of moments, and on that the principle of screw gauge works. Okay, And this measurement is used to calculate the small lengths. Okay. And that is, therefore, the pitch of the screw is the distance moved. This is the principle of the screw, and that is that is also known as the pitch of the screw. It is the distance moved along its axis by the screw in one complete rotation of its head. When I'm moving the total complete rotation of the head, that is of the screw, of the circular scale head, when I'm moving the total ratchet once, how much the how many divisions of the main scale has it moved? Okay, that gives the pitch of the screw. Now the structure, as I've described earlier, that screw gauge consists of a U-shaped metal frame to which a hollow cylinder is attached. There are grooves on the inner surface of the cylinder through which a screw passes. Okay. Now on the cylinder, there is a scale that is parallel to the axis of the screw, and it is graduated in millimeter, which is known as the pitch scale or main scale. The cylinder has graduations along its circumference, and that is known as circular or the head scale. Now the circular scale generally has 50 to 100 divisions. Okay, and generally the pitch of the screw is 1 millimeter, or you can say 0.5 ml. It can be 1 millimeter or 0.5 millimeter. Okay. Next, we come to the least count. Then the least count of a screw is the distance moved along its axis by it in rotating the circular scale by one division. That is, when I'm rotating the circular scale by one division, when I'm taking the circular scale by one division, then how much the distance of along the axis the screw has moved. That is the least count. So least count will be pitch of the screw by total number of divisions of the circular scale. Okay. Now the least count of the screw can be decreased. It can be, how can it be decreased? By decreasing, if I decrease the pitch or increase the total number of divisions of the circular scale, then we can decrease the pitch, decrease the least count. Okay. Then there are certain errors which come, okay, in the instrument. First is backlash error. What happens? Due to the wear and tear, the threads of the screw does not allow the movement of the tip of the screw in the opposite direction when we are moving it anti-clockwise direction. So what happens? The screw, due to the wear and tear, the screw does not allow the movement of the tip of the screw. Okay, when this thimble is rotated in the opposite direction, then what happens? The screw does not allow the tip of the screw to move for some time. It becomes stationary for a part of the rotation. That is backlash error. That means the division is not counted when I'm moving the total, I mean, on the reverse direction when it is moving. So that becomes an error. Okay. Then another error is zero error. Now, zero, what is zero error? We have studied in vernier calipers also. There also the vernier, the zero of the vernier and the zero of the main scale, if it coincides when the these jaws are in contact, when these two zeros coincide, then the instrument is free from zero error. If it does not coincide, then only the instrument will have zero error. Like that, in the screw gauge also, when the flat end of the screw coincides with the stud, okay, if the zero mark of the circular scale does not coincide with the baseline of the main scale, that is the axis of the main scale, the axis of the main scale, that is this one. See, if the zero mark of the circular scale, if it is a zero mark of the circular scale, if that does not coincide with this axis of the main scale, when this and this are in contact, A and B point are in contact, then if the baseline does not coincide with the zero mark of the circular scale, then the instrument will possess a zero error. Okay. If the zero error, it can be positive or negative. Now, if the zero of the circular scale is above, or rather it is below the baseline of the main scale, then the instrument will have positive zero error. Okay. And if it is above the zero, above the axis of the main scale, if the zero of the circular scale is above the baseline of the main scale, then the instrument will have the negative zero error. Now, how to find out? Do we need to calculate the positive zero error and negative zero error? For positive zero error, the number of circular scale division coinciding with the baseline of the main scale, that is when we are putting the studs together, that is the A point and the B point, this screw point, flat end of the screw point and the stud, when they are meeting together, at that time, when we are seeing that the baseline is not coinciding with the zero mark of the circular scale, at that time, what do we see? The some point, some division of the circular scale is coinciding with the main scale, with the main axis of the main scale. Then that division of the circular scale into the least count of the screw gauge will give the positive zero error. Okay, for positive one. Now for the negative one, the total number of division of the circular scale. What is the total of, say the circular scale has 50 divisions or 100, say 50 divisions it has. Okay, now that 50 minus the number of the circular scale division which is coinciding with the baseline of this scale. Again, when the studs are in contact, that is the stud and the flat end of the screw, when it is contact, when they are in contact, and that time the zero does not coincide with the this one axis of the main scale, and the zero is above the baseline of the main scale, then what happens? We find out the division which is coinciding with the main scale, which is the coinciding with the baseline of the main scale. That division is subtracted from the total number of divisions of the circular scale. In multiplying it that by the least count of the screw gauge will give you the negative zero error. Again, like the vernier scale, for correct reading, we need to subtract the zero error with the sign from the observed reading. First, that is for the zero error, positive zero error, we need to that observed observed reading minus as it is positive, so we write a plus sign before the zero error, so we get plus and minus, multiplying it will become minus, so observed reading minus zero error. Then for negative zero error, observed reading minus zero error, that is as it is negative, so that becomes minus into minus, that is plus. So we add the zero error for negative zero error to get the correct reading, and for positive zero error, we subtract the zero error from the observed reading to get the correct reading. Okay, another see, this is the difference. This is the picture you can see when the zero of the this is the axis of the main scale reading that is coinciding with the zero of the circular scale reading, so therefore there is no zero error. When the zero of the circular scale is below the main axis, this is baseline of the main scale, then what happens? It is positive zero error. And if it is the zero is above the baseline of the main scale, then it is negative zero error. See here, we can see that 1, 2. So second division of the circular scale is coinciding with the zero of the main scale. I mean, not zero, it is the baseline of the main scale. So we will see for positive zero error will be 2 into the least count. Okay, and for this one, see this circular scale, it has say it has 50 divisions. So 50 minus here, what is coinciding? 1, 2, 3, and 4. So fourth mark is coinciding. So 50 minus 4, that is 46 into the least count will be the negative zero error. Okay, I hope you've understood. Next, we come to how to measure the diameter. Another error is there that is known as parallax error. Okay, and in this what happens when we are seeing the when we are observing the error, I mean the reading, when we are taking the observations, when we are taking the observation of the observing the reading. So when we are seeing from different directions, due to the thickness, it can provide you an error. We can get a different reading. Okay, we can see that some other mark will be coinciding with the main axis. Okay, baseline. It's like this. See, if we see straight, then the axis will be, say, 0 is coinciding with the baseline. But if we see from this angle, we can see that 0 is not coinciding, and maybe this one is coinciding, this one mark is coinciding. From, if we see from here, then we can see that for 46 mark, 49th mark is coinciding. So like this, there will be parallax error. So correct view will be from we need to see from the you have to see straight, so that too we avoid this parallax error. Okay, another is due to the wear and tear. I told you, if the graduations does not meet, then we can have this backlash error. So now how to measure the diameter of a wire of the screw? See, now what to do? For taking a measurement, first we need to find out the least count of the instrument and zero error. If the instrument of that is the screw gauge is having zero error or not, then we will turn the ratchet or the thimble in the anti-clockwise direction, so that there is a gap. After finding out this least count and zero error, we will just turn the thimble or ratchet in an anti-clockwise direction, so that there's a gap created with the start and the flat end of the gauge, and the wire which we need to measure the diameter, we place it in the horizontal direction. Okay, the main scale reading is taken, and the division of the circular scale, say P, which is noted, which is coinciding with the axis of the main scale, we take it down, take down the reading. And so the circular scale reading will be P's division, which is coinciding with the main scale, baseline of the main scale, into the least count will be the circular scale reading. Then the circular scale reading plus the main scale reading will give you the total reading. And if the instrument possesses zero error, then it is either, this zero error is either subtracted or added. If it is positive zero error, then it is subtracted. If it is negative zero error, then it is, it is added to the total reading, which will give the correct reading. So for first, we find out the pitch of the screw, then the number of division of the circular scale, then the least count, which is pitch of the screw by total number of division of the circular scale. Then we find the zero error, and then we take the readings, and then we will get the correct reading of the correct diameter of the wire. And for one thing we need to do, that is we need to take 2 or 3 readings. Okay, say we take 3 or 4 readings. Okay, and then we find out the mean of them, because there can be some error also for when we are, that is called backlash error, and also some parallax error can also be there. So for that, to avoid that, we take 3-4 readings, and then we take out the mean of that, and then we subtract the zero error from them, and then we get the correct reading. Okay, and next, okay, okay. Now this is this is about the screw gauge. So I think you have understood it. Please go through this. If you have any doubt, please do let me know. Please do write in the comment box, or you can also access my email ID, that is kasturi74@gmail.com. And also you can do this one. What do you say? You can access my Facebook account also. Okay, Moshok is there. Okay, if you have any doubt, you can also write it there also. And also one more thing, that please do subscribe, so that you can get the notification of my next video, and press the like button, share with your friends. And one more thing I want to tell you, this is not the least, but okay, you should meditate before sitting for studying. That will increase your concentration, especially during examinations. You need more concentrated. Okay, you need to be more concentrated on your studies so that you can have a good knowledge of it. I know you are sitting in the house, still not going to schools, and so you are this one not able to study properly, bored with the studies. So please do meditate to avoid these things, and then you can do some relaxation. You will feel some relaxation, and you will be able to concentrate on your studies. And thank you for watching, and have a good day.